How's everyone doing today? Awesome. Thank you for coming. So, change of plans. So the talk that's on the slides, like the projected talk is no longer the talk that's happening. So I revised my talk for this last minute because I was kind of inspired by just thinking some more about diversity and what diversity means for me as an engineer. So if you are interested in refactoring or interested in prototyping and don't want to hear about linguistic diversity, which I'll explain a bit, for you to walk out at any point during the talk, I won't shame you. So today's talk is called Linguistic Diversity Beyond Object-Oriented Programming. This talk is a version of a talk I gave at ElixirConf as the keynote, which was originally titled Linguistic Domination and Translation as Counter-Hegemonic Practice. This title is very long, and I could also simplify this to like what comes after Java, or screw Java, or Java is not great. But this is like the intellectual way that my professors told me I should say things. So who am I? I'm Osa Gaius. I work at a company called Mailchimp, and I help build the world's largest marketing platform for small businesses. So let's kind of talk about why this talk came to be and how things originally occurred. So what originally happened was I gave a talk last year at ElixirConf where I talked a bit about the Elixir programming language, which if you're not familiar with is a functional programming language that looks very similar to Ruby and feels very much like Ruby or Scala, but is based on the Erlang virtual machine. And so what I was talking about there at that talk last year was how do we take a language like Elixir that's still very niche and still very sort of isolated, and how do we sort of widen its popularity, right? But what I'm more interested in is how do we get more people writing software in languages like Elixir that are functional languages. So in that talk, I sort of espoused reasons why the Elixir language historically has failed to gain momentum and what that means for the community. And so in this talk, I wanted to really understand how exactly it is that languages become popular. How is it that we end up using certain languages at work? What does that mean for us as programmers? And how do we move beyond that sort of limited set of languages if we do care about them? So if we sort of take it back, I was told to write this talk initially, and I started sort of thinking about ways to begin to talk about those things. And to be honest, I struggle with giving a talk like this for many reasons, because although I was excited and very happy, I was sort of a little scared, right? Because the kind of talks that I usually give are very like in-depth, like a bunch of code, a bunch of like talk of monads and like all these high-level concepts in computer science. And this talk instead is more about like what it means to be a software engineer and how I wrestle with the languages I choose. And so I chose to give this talk regardless of that because I think there are several important concepts, and I'll start walking through these. But the outline for this talk sort of operates as follows. First, I'll talk about what I mean by hegemony, which you might have seen earlier, what I mean by object-oriented programming as sort of a hegemon. I'll talk about hegemony in sort of particular instances, and then I'll talk about translation, which I think is a useful way to resist the status quo. So let's kind of talk first and foremost about what hegemony means. So hegemony, the term hegemony originates from the Latin word hegemonia, which originally sort of is a term that defines domination, influence over one political group over another. So in the typical sense, you can think of hegemony as being military power. So in the case of the US, we have hegemony over every other country in the world, over China, Russia, so on and so forth. And a challenge to our hegemony or a challenge to our domination is an act of war, right? So if China moves certain fleets into parts of the Pacific, like that is considered an act of war. So hegemony in one sense means physical, literal domination by one party over the other. But the second form of hegemony that I think is more interesting emerges from sort of French and Italian philosophical work. And the argument here is that hegemony is not necessarily physical, right? It can be in the realm of ideas, through thought, through language, so on and so forth. So if we think, for instance, of institutions that we sort of are beholden to, like the church, the news media, the school institution, like these are tools of hegemony. They're tools of power. They're tools of control in the population, right? Not in some sort of like conspiracy, like tinfoil sense, but in a literal sense, right? We get information and we decide how to become human beings through these institutions, right? They affect our thought, they tell us how to think, what is within the norm and what is outside the norm. Now, if we extend this, we can think of one form of hegemony that's particularly interesting, which is the idea of a lingua franca, right? A lingua franca is sort of the accepted language, right? But in the case of, in the modern world, English is a lingua franca, right? So you take an instance like, of me. I was born and raised in Nigeria. I came to America as a kid, and I only speak English, right? That is literal, sort of lingua franca domination of the realm of ideas, right? People who live in certain countries outside the US do not speak their native language because the accepted language of the world is English, right? So we can think of English as being a sort of dominant language because it dominates the discourse even in countries where people are not supposed to speak English natively. Now, what's interesting about this notion of hegemony is that for Italian theorist Antonio Gramsci, this idea of hegemony doesn't operate by force. In other words, no one came to my little small town in Benin City, Nigeria, and beat me every day to learn English, right? So like no white colonizer came and beat me and taught me English, right? Rather, my mom made me speak English, right? Because her parents made her speak English because that was what it meant to be successful in the world. So I think this is interesting because hegemony for Italian and French thinkers is not about me forcing you to do something, but creating a situation in which you making that decision on your own is the best way to sort of, for you to live your life. Now, what's interesting, I think a good analogy here is to think of, the mob, right? And sort of the classic mob movies, right? The mob never tells you, you should do X or you should give us X. The mob, rather, in sort of a comical way says, it'd be in your best interest to do what I tell you to do, right? It would be wise for you to do X or wise for you to do Y. And that's interesting because that is how power operates at the realm of hegemony rather than by domination in the sort of classical international relations theory sense. So, what do I mean then by object-oriented programming as an hegemon, right? What do we mean there? I think we can think about this in two sort of axes. I think the first is when we look at the languages that are popular, we can clearly see at the top languages like Java, C, C++ are sort of traditional object-oriented languages that have a particular paradigm as to how they want us to write computer software, right? And that's not necessarily bad, right? So this is merely an observation of the status quo. And then secondarily, if we look at the number of jobs, right, that people are posting, we can also see that these object-oriented languages like Java, JavaScript, so on and so forth, are still dominant, right? So either by way of looking at popularity of languages, or more importantly, by looking at the number of jobs that are being offered, we can see that there's sort of a clear dominance. Now, when we look at what dominance means, I think it's interesting to think about how did, let's say, Java in this case become a hegemon, right? And so we have to go back and look at some microsystems in the 90s and begin to think about, well, some microsystems invented or came out with a language that they wanted to popularize, right? In order to sell servers and to sell server software. And that language was Java, right? And they began this mission of trying to make Java the language that would dominate all the languages. It's also interesting to note that they actually wanted Java to be a browser language. They wanted Java to beat JavaScript. And then they miserably failed at that. And so they obviously pivoted to, let's say, let's make Java a server-side language for that middle tier, right? For systems programmers. Now, this is interesting because when you look back at the literature, you can see there's a clear, sort of effort on the part of the Java practitioners and the Java language practitioners to actually make sure that their language won, right? And so we can look at sort of articles like this where it says, why Sun thinks hot Java will give you a lift, right? And what's interesting about this is not a news article in Wired magazine or in a sort of random techie magazine. This is primetime news for the average reader, right? And so you see this push all over the 90s of language practitioners at the Java Sun Microsystems group to actively push their language utilizing the media. And as we discussed earlier, the media is one of the useful tools in society to spread a message, to create hegemony, right? So we can literally see here their creation of hegemony. What's also interesting is Eric Schmidt, the former chairman and CEO of Google, but before that, a vice president at Sun Microsystems, who was instrumental in making sure that Java won. He describes their efforts like this as quote unquote part of a war, right? And I think that is apropos, right? Because when you look at sort of Italian theorists, when they talk about what hegemony means, they talk about how you have to win the war for ideas. And so it's beautiful to see Sun Microsystems in the 90s clearly state that we are in a war to make sure our language wins, even if our language is less superior, right? Even if it's less technically interesting, we want to win this war. And they go about that in a very interesting way. And you can even see sort of other articles where they talk about this universal software language, right? This was part of their attempt to co-opt the language of other communities and talk about these ideas of universalism, the language that can run everywhere. Even if those things weren't necessarily true, at a marketing level, they did what they needed to do to make sure that Java won. And of course, we had a new hegemon, right? So Java now overtook languages like C and C++ as the primary language for building business applications, right? Languages like Fortran, et cetera, that still were big parts of how mainframe software written became irrelevant, right? Because now Java had successfully done what they needed to do. And I think it's important to pause here because I think for most of us, we may assume that Java is this ubiquitous language. It's always been here, but it's relatively new, like less than 40 years old in terms of actual dominance. And you can see the growth of Java from being irrelevant as a language to being extremely relevant. And I think what matters there is that there was a concerted effort to claim hegemony by the part of the folks at Sun Microsystems. And that is beautiful to see, although let's talk about why that's problematic. So we'll start by talking about two areas where we can see dominance and hegemony play out. The first is what we call the Big Four. The Big Four, as some of you know, refers to the big four technology companies that sort of shape how modern consumer technology works, right? We can think of Facebook, Google, Amazon, and of course Apple. Eric Schmidt, again, the CEO of Google, former CEO of Google, actually coined this term for the Big Four because in his mind, these were the only companies that actually mattered, right? Now, if you think about that, most of these companies, if you want to get a job there, they make you take a programming test, right? And the test is interesting because the Italian or the French theorist Michel Foucault talks about these tests that we take as not just being useful to prove our knowledge, but they're tools of discipline, right? In the sense that they make sure that you are aligned with what current knowledge is, right? So in the case of me as a Nigerian, I take an English test, not just to prove that I can speak English, but to prove that I'm aligned with the American Civics Institution, right? So I recently went for my US citizenship test, and they made me write a few words in English to prove that I was aligned, not just with English as a language, but with a wider institution that is America, right? It's a wonderful thing, it's a great thing, and I'm glad to be here. However, we must admit and look at theory and understand that languages and tests about languages are actually tools to make sure that you're aligned. So if we look at the Gang of Four, or rather the Big Four, we can see that each of them requires you to, so it's funny because if you understand, we'll walk through it in a second. Gang. But if you look at the Big Four, Apple, Facebook, so on and so forth, they make you take a test, right? And all of these tests are essentially in Java, right? Sometimes you can do it in a different language, but you are strongly encouraged to do it in Java, right? You are strongly encouraged to do it in an object-oriented language. In fact, your recruiter will play this game with you of cat and mouse, right? Where they're like, you don't have to do it in Java, but here are a bunch of materials in Java. And if you don't do it in Java, well, maybe you should do it in Java. And I recently went through this because as an undergrad, I worked at a bunch of artificial intelligence labs, and somehow those are feeder pools for Google's AI labs. So I somehow found myself on this list of people that Google out of school wanted to recruit, right? So senior year, I get a bunch of emails like, hey, come interview at Google. Hey, come interview at Google. And I'm like, nah, I'm good. Every year I get the same email, right? Come interview at Google. And I'm like, I'm good. Got a good job. I like Atlanta. It's great. I kept giving these excuses for why I did not want to interview at Google. And eventually I had to admit, I hate your programming interviews. I think they're terrible. I think they're a bad proof of intelligence. All the studies say they're terrible. Stop doing them. But they were like, no, that's how we do interviews. So you have to interview that way. So I said, okay, cool. I'll interview, it's a free trip to California. My best friend lives there. Let's do it. So I pass all their interviews. I get to the final round where I got to fly out and do all the fun stuff. And I decide to really examine myself and say, why am I actually trying to interview in this language? But before we discuss my own experience, let's talk about this other Gang of Four, right? The other Gang of Four refers to the four sort of authors of the popular book on programming design patterns, right? And the Gang of Four can also be interpreted as a series of design patterns you should know, right? You can think of them as strategy, adapter, so on and so forth. These are classic patterns that in school you have to learn, and if you don't learn them in school, at some point in your job, someone will reference them and you'll have to like figure out what they mean. But what's interesting about the Gang of Four is they are essentially only object-oriented design patterns, right? They are primarily for building object-oriented pieces of software, right? They assume certain things about inheritance and composition and why those things are necessarily good. Now, what's problematic about that is, of course, we know that the best way to build pieces of software are not necessarily in object-oriented systems, right? You can build languages or you can build systems in any language, in any pattern, and they will be really interesting, right? But what's interesting is that when you go to work as a programmer at most companies today, if you do not know the Gang of Four, at some point during the interview phase or during the pull request phase, you will be encountered with this test of intelligence, right? Which is, do you understand object-oriented programming? And if you do not, are you really a competent programmer, right? And I think that is interesting because, of course, you can be a competent programmer and have never heard of the Gang of Four, right? Because the Gang of Four is relatively new as a programming pattern, series of patterns, right? But what's interesting about that is the fact that it has become, in a way, a lingua franca for how we decide that languages or decide that pieces of software should be written. And that, I think, is inherently dangerous because, of course, it is only about object-oriented design patterns. It is not about the myriad other patterns, whether they be dynamic languages, functional languages, so on and so forth, that can be used to build robust, resilient pieces of software. So, how do we resist, right? So I got to this point, I wrote this talk, I started giving versions of it to myself, and I was like, at some point I'm gonna get here and people are gonna be like, well, you hate Java, and you hate Java programmers, and what am I supposed to do? Like, throw my hands up and like not get a job? How do you go about resisting this, right? Gramsci, the Italian economist I just mentioned, says, you can't really resist hegemony at the level of force, right? You can't have a frontal assault on hegemony, right? In the same way as I cannot, refuse to take the American citizenship test because I don't believe that English should be the lingua franca of the world, right? I can't do that because I need my citizenship because, you need that. But we must resist in some way, right? Like, we cannot just let power dominate us. We have to find some way to begin to, bring up ideas. And so Gramsci says that what we need instead is a war for ideas, right? A war at the level of ideas. That we have to confront these sort of dominant powers, not, by physically assaulting people, right? So don't go beat up Java programmers. That's not what this talk is about, right? Rather, it's that we have to counter the ideas that are dominant, right, at the level, at the moment at which ideas are being debated, right? And so I think of tech conferences as a place in which, like, we're supposed to share ideas and talk about what these ideas should be that we go forward and use as programmers. I think of the programming interview as a moment at which ideas are being contested, right? Your intelligence is actually being called into question, right? So what better place to confront power and to confront the test of intelligence? So this brings us back to my Google interview. So I was in Nigeria over the winter break for all December, seeing my family who I haven't seen in 20 years. And so I said, well, I've got 4 weeks in Nigeria. I'm going to use part of this time to study for this Google interview, which got my dad really excited, because he was like, Google, I've heard of it. It's a real American company. You should get a job there. Which sort of belies this point, right? That for the average programmer, the Gang of Four, right, or the Big Four, should not just be thought of as, these cool companies that you might go work for, right? But they are the companies to work for, right? In other words, they are the height of your success as an engineer, right? For me as a child of immigrants, working at Google is not just about, whether or not I get a job there. It's the American dream for my parents, right? I brought my kid to America. He now works at Google. Success achieved, they can retire. Right, so for me, I think it's interesting to think about the fact that the Big Four represent this signal, right, of success, right? They represent this signal of engineering excellence that if you do not get into the Big Four, if you do not achieve that level of excellence, you have to call yourself as a programmer into question, right? You will always know that you never worked at Google. And we can say, well, Google sucks, it's terrible, they don't respect privacy, right? But you always know that there are costs associated with that. The first is the career cost, right? Your career will be net better if you work at Google if you did not work at Google, right? Like you'll get better jobs, better comp, so on and so forth. So I think there's something to be said for the fact that there is this sort of North Star, which is the Big Four, and that the only way to get into that sort of gate is to actually go through the program interview test. So I'm in Nigeria, I'm studying this book called The Cracking the Coding Interview, which is literally all the questions they will ask you in the Google interview, like listed out. And you just have to like cram those, and then you pass the test. And yeah, it's great, it's awesome. But also interesting that you can cram for a test of intelligence. So I'm going through it. These exercises are all in Java, a few of them are in C++. So I've got my pencil out, my pen. The power is off at night in Nigeria because we don't have 24-hour access, so I've got a candle going. And I'm working through these exercises. I'm feeling great. I'm solving all these problems. And at some point, I start thinking like, this is odd. This is very odd. So the first example I'll give is there's this programming exercise. We have to build a least recently used cache, right? So implement a cache, right? And then your goal is to remove the least recently used item. So I sort of think about this in the first instance, right? Before I show any code, I'll sort of talk about what's happening to me here. So I'm at night, I'm solving this, over candlelight, and I'm like, oh, okay, I've got this. I can do this Java implementation. This is pretty good. And at some point, I sort of start thinking about this, and I'm like, well, what would be truly radical is if I did this in not Java. What if I went to the Google programming interview, and instead of coming in with a language that my recruiter has, on multiple occasions in a passive-aggressive way, told me I should use, what if I come into the interview and I use my language of choice that I use at home for my work, which is Elixir, right? Language I have the most experience in. And at first, I'm kind of scared, right? Because I'm like, this is gonna be, I probably won't get the job, right? Like I probably will have some issues if I do this in a language that's not Java. But I decide, let me try it, right? So what I try to start doing is I take all of the coding exercises I've been doing in Java, and I start converting my solutions into Elixir. And the first one is this LRU cache, right? And in Elixir, and I won't bore you with code here, but essentially in Elixir, you create some server, some instance of a server, in this case an agent, and then we simply keep the queue, we have a store, and then we keep our capacity so we can pop items off. And implementing the get operation is pretty simple. You just add things to your queue, you update the queue, or update the cache rather, and you update the queue, the state of the agent to have a new queue and a new store, right? It's relatively simple, relatively trivial operation in Elixir, and what I want to talk about here is what happens when I'm done, right? So I write this translation, I work through a few more examples, and I'm like, something's wrong. And what's wrong is this. The requirement in the coding exercise is that your get and put operations from your LRU cache have to be O of 1. They have to be in constant time, right? And if you know like functional languages more generally, the basic idea is that you do not mutate state, right? In other words, you do not mutate things in memory. There is no shared memory. Every single process, every single operation happens in isolation. So if that's the case, you have to have some way to represent an array in memory that doesn't allow your processes to share the same array. And one way this is achieved is by using an HAMT, which is a hash array map trie, right? So that when you have a new thing you want to add, you simply have a hash array map trie behind the scenes that stores all the values that you're storing. And this is different than an array structure in a language like Java where you can access memory because you can just simply have one process that maintains your cache, and that process individually can make changes to memory, and you can have O of 1 operations, right? Because you can share memory between processes rather than by creating a new entry here to store the new thing you're trying to add. So what this means generally is that using HAMT, which is the way that all array-based structures and maps are implemented in languages like Elixir, Scala, so on and so forth, you can never achieve O of 1, right? That's impossible because the best you can do is O log n, right? You can get logarithmic time, but not constant time because that is how you preserve immutability. So I'm here, in Nigeria, and I'm like, okay. So the problem asks me for O of 1. that's impossible in a functional language. So how am I going to explain this in a programming interview, which is already short, it's 30 minutes. Now I have to like teach this person HAMTs or like assume they know what that is. And then we have to talk about, well, like if your thing is logarithmic, like over time it becomes constant just as your data increases. So like it's generally fine in production, even though in theory it's not fine. And then I realized something was amiss, right? Because I was now wrestling with like, well, okay, maybe I can hack the Erlang virtual machine and create my own mutable data structure that would let me like do constant time operations. I was like, wait, no, that's the entire point of immutability, is to not mutate state in memory. And I realized this is the magic trick that the programming interview test at Google and the other big four does, is it takes what are actually hard, true computer science problems, right? Which is, how do I represent large amounts of data? How do I process large amounts of data in a way that's safe and resilient, right? Which leads us to use HAMT, right? Or an immutable data structure. It changes that real problem, which we actually have as software engineers, and reduces it to some theoretical, what I call a fanciful game, right? Of, well, how could you theoretically do this? And it's like, well, theoretically, I could use a terrible data structure that in production would cause issues and would corrupt data and would probably cause bugs, but I would not theoretically do that because that's a terrible idea. And this is, I think, precisely what the programming interview does, right? Is it tells you, well, do this in constant time, even though doing it in constant time requires you to use a terrible data structure that in production means you'll probably have bugs, or you have to implement some sort of scary, weird locking mechanism so that you're locking pieces of code so that no other process can access it. In other words, build a system that is terrible because it's not actually able to be concurrent, which in a world where Moore's law flattens out, you need concurrency. So it takes what are real problems that we as engineers have, and it reduces it to this game, right? This is a beautiful magic trick, because you as an engineer begin to doubt your own intelligence, right? Because you are not sure whether or not your core ideas about computer science are even correct. So the other interesting thing I sort of looked at was factories, right? Because in this cracking the coding interview problem set, they have lots of use of the gang of four patterns, right? There's lots of adapter patterns, and it's like core of the book, right? There are even parts of it where they're like, just say you know the pattern, and the interviewer will give you like a few points, just by saying you know the pattern, right? And that was interesting because I started looking at some of these patterns, and one that I looked at was this factory pattern that I'm sure you're familiar with, which is, you know, I need a factory that will give me something, right? And so I can send in a constant, like I want to create a cat, and that will return me a new cat object, create a bird, that will give me a new bird object. So you just have a thing that matches against all of these. Now, what's interesting about these is if you've ever worked with these kinds of factory patterns, they are notoriously difficult to debug, right? Because if I am, let's say, just writing a piece of code and I'm like, well, I need a rabbit. How do I get a rabbit, right? I have no idea how to get a rabbit. Because I first of all have to find this class, then I have to like grok the fact that this class is doing some sort of pattern matching based on these constant defined somewhere, right? And so it takes me, and usually I deal with this code a lot because it's very popular in a lot of OO shops, right? And I have to take like a minute or two to be like, oh, okay, I see what they're doing. They're doing some sort of inheritance situation, but they're using this to represent it. Now, what happens if you try to do this in a functional language, right? Let's take Elixir. This is the same code, right? It does the same thing. If I want to create a cat, I just pass in the name for the action, and I give the type, right? Now, what's interesting about this is that, in my opinion, when you're doing, let's say, 20 of these, it's very, very easy to read this. It is not very easy to read a 20-line switch statement, right? You can simply read 21-liners that are just like, create a cat, do this, create a dog, do this. The other thing to keep in mind is that all of these objects here are all the same thing, right? They're all just bare instances with some additional data attribute. In this case, it's just their type, right? So this begs the question, if I'm just doing some sort of type-based creation and returning some data, why not just do it in a way that lets me cleanly do this in a series of one-liners? And the argument I would probably give to you is that it's because object-oriented languages, by far none, have no ability to do pattern matching and function headers, right? And they move you away from doing simple type definition and returning simple objects, right? Instead, they want you to return these objects that can be stored in memory, that have attributes, so on and so forth, rather than just plain pieces of data. And this is what you see in the functional communities like Clojure, Elixir, so on and so forth, is this emphasis on simplicity, right? Code readability, as well as simply using data rather than representing larger objects that need a bunch of information. So I think when I came to this and I started thinking about all these different patterns, I began seeing that lots of patterns that I was sort of used to were actually, from an OO perspective, attempts to fix the fact that the languages were inherently problematic, right? So we were fixing language deficiencies by inventing patterns rather than by fixing the languages themselves. What's time, by the way?
You have about 5 minutes left.
Awesome, thank you. So let's kind of wrap up. So what ended up happening was I flew to Cali for the interview. I got sick the day before, so I rescheduled the interview, and they said, well, come back next week. We'll fly you up here. And I got back, and I was like, no, I'm good, right? And to me, what's interesting there is I essentially decided not to interview because I talked to a bunch of friends who work at Google, and they were like, yeah, if you don't want to do Java, don't come here, right? Like, why would you ever do that? And I was like, well, like, I'm revolutionary, I'll just come and revolutionize things. And they were like, no, like, you're gonna come here and do Java. Like, do you wanna do Java for X amount of money? And I was like, no, that's fine. That money is not better than current money, so I'm not gonna go do Java. And I think that is interesting. So what I'll say in conclusion as I sort of think about like what comes next is I'm not really interested in overthrowing Java or saying Java is bad. I think we're at a conference where we're talking a lot about diversity, and we're talking about diversity in terms of like, color of skin, gender, so on and so forth, but I'm interested in linguistic diversity, right? The diversity of tools that we use as programmers, right? Because the truth is we are restricted to a certain kind of tooling, especially the big four, and that permeates programming culture, right? There is a certain type when it comes to a Java programmer. And if we are to move beyond the current state of programming and what it means to be a programmer today, I think that requires not just rethinking what programmers look like, but more importantly, what programming work looks like, right? So for instance, what does it mean to be a programmer if you went to a boot camp and you never learn what the gang of four are? Are you a less interesting programmer? Are you a less competent programmer? I would argue no, because I don't think the gang of four are that relevant anymore, right? I think we've moved beyond those patterns. So how do we begin to understand both new arising patterns, right? New arising tooling and languages, as well as languages and patterns that have been, swept to the wayside by the dominance of the Java marketing campaign? How do we begin to bring those tools back and embrace new tools that help us solve real problems in today's world? Because the truth is the problems that we encounter today are radically different than the kinds of problems that Java was invented to solve and are radically more interesting, right? But the question is, how do we begin to understand that linguistic diversity and that tooling diversity that we'll need in order to encounter and solve those new problems? I don't have a good answer for you on that. I would say that at an individual level, you have to begin to resist, right? You have to begin to question how you write software, the gaps in your own knowledge, and you have to begin to seek those out. I think translation is a good one. So thinking of problems that you solve in JavaScript like very simply, and thinking about how would I solve that same problem in Elm, right? If you cannot do the work to get there, I would argue that that is the sign of a lack of diversity in your own thought, right? So that's the work I think should be done, not necessarily fighting against Java. I think the second thing that ought to be done, and I've sort of started working on this with the Elixir community, is to really think about how do we market ourselves, right? I think as engineers, we tend to be like very quiet and like reserved. And so if your boss says like, hey, let's use Java, you're like, sure, let's use Java, right? But we have to speak up, right? Both at the sort of company level, but also at the organizational level, right? So for me, that means working on advocacy for the Elixir community, outside the Elixir community. It means running workshops. It means running the Atlanta Elixir Meetup to educate folks. It means going to conferences like this one that are not about Elixir and telling you like, hey, functional programming is great. You should probably check it out. Probably expand your tool set, right? So I think that's part of the work, is both at an individual level, at a company level, but also at a sort of community level, making sure that we're doing the work to bring folks in who are different, and also going to folks who are different from us and spreading the message of whatever paradigm we think is interesting. And with that in mind, thank you.